Namaste students. Today we are going to start with next topic of our integrals, that are some standard forms. We have three standard forms. If you look at these forms and you recall, we did the similar forms in denominator. Remember, 1 upon under root x square minus a square, 1 upon under root x square plus a square, 1 upon under root a square minus x square. So now we have these forms in numerator. We are going to do the integral of under root x square minus a square, under root x square plus a square, and under root a square minus x square. Alright children, so these are the three formulas. You are going to add these formulas in your concept notebook where you have written all the formulas of integral. So you have three more additions to your formula. If it is under root x square minus a square, the formula is x by 2 under the root x square minus a square minus a square by 2 log of x plus under root x square minus a square. Remember, this was the integration of 1 upon under root x square minus a square. So log of x plus under root x square minus a square plus c. If I have x square plus a square, then x by 2 under root x square plus a square by 2 log of x plus under root x square plus a square plus c. And if I have under the root a square minus x square, this was x square minus a square. If I have a square minus x square, it will be x by 2 under the root a square minus x square plus a square by 2 sine inverse x by a plus c. Alright, and definitely you have to learn these formulas, because when the question comes as a part of some of the question, you have to write the formula directly. Otherwise we can drive it also. Let's try the first one. Remaining two you will try on your own. Alright, I have to integrate under the root x square minus a square. Clear? So we are going to use by parts here. I don't have a second function, so I'll take into 1. Now by parts, I hope you have seen the previous videos. You have done by parts, integration by parts. Alright, so we are going to apply. What happens in by part? We use the word islet to choose the sequence of the functions to be taken as first or second. Here this is algebraic, and the constant. Definitely I will be taking the constant as the second one. So this is my first function. First function as it is. Integration of second. What will be the integration of 1? The integration of 1 would be x. Minus sign of integration. What will happen? Differentiation of this. I have to differentiate under root x square minus a square. कैसे होती है differentiation? First of all, the differentiation of the power. The power comes in front, reduce the power by 1. Into differentiation of internal function x square minus a square में differentiation क्या हो जाएगी? 2x. Into integration of second, that is x. Alright. So what do I have? 2 and 2 cancel. I have x square upon clear. So what am I doing here? Now see, I have x square upon under root x square minus a square. ठीक है, अब इंटीग्रेशन कुछ सोचना पड़ेगा. कभी ऐसा हो जाए इन केस यू हैव x square minus a square और ऊपर x square है, सिर्फ ये वाला कांस्टेंट मिसिंग है, तो हम कांस्टेंट अपने आप इंट्रोड्यूस कर सकते हैं वहां पर. कैसे? I will add and subtract a square. No harm in that. I will add and subtract a square. Clear? Add and subtract a square. So it has become segregate. This separate. Alright children. Now Here what is left? X square minus a square, the power is 1. X square minus a square, the power is half. ऊपर the same term की power 1 है, नीचे half है, तो ऊपर क्या रह जाएगी? Half. And I am going to segregate the integrals also. A square is constant. Take it outside. Alright. Now, see to it. What is this? This is I. That is I. So I'll put I in that place. And recall the formula. See, when you're doing some integration, you can't forget the previous one. That I've told you number of times. So what is the integration of 1 upon under root x square minus a square? Remember, what is the integration? Log of x plus under root x square minus a square plus c. Alright, I will come this side. This 2 will go that side. And c by 2 again can be written as some constant. So the integration of under root x square minus a square is x upon 2 under root x square minus a square minus a square by 2 log of x plus under root x square minus a square. Clear, children? So same way we can prove second and third one also. Though you have to learn the formulas, because when it will be a part of the question, you don't have to drive it. You have to directly apply the formula. But suppose this question comes as it is to solve. There, if suppose comes in 4 marks, so directly you can't write the answer, no? Then you have to solve it and show it to you. So we'll pick up examples of these 3 standard forms. Let's take some examples. Integration of under the root 25 minus x square. So, I can write it as 25 as 5 square. So, directly which form is it? Integration of a square minus x square. Integration of a square minus x square. What is the integration? That is x under the root a square minus x square by 2 plus a square by 2 sine inverse x by a plus c. Clear? So directly we can apply the formula. It would be x under the root x square minus x square by 2 plus a square by 2 sine inverse x by a. That's it. Now similarly come to the next one. Now any of the form which we have done 3 standard forms with x square there is no coefficient. That was the same condition there also when we did these forms in denominator. Fine, so x square should not have any constant. So I coefficient. So I'll take this root 3 out. That's it. Which form? Under the root x square plus a square. So what is the integration? X by 2 into x square plus a square plus a square by 2 log of x plus under root x square plus a square plus c. Just simplify. You want to take LCM. This root 3 will come out here. This root 3 will come here also. Alright. And inside LCM first of all, then outside. By root 3 plus c. Alright, I can cancel this, so that is my answer. Is it clear to you? Directly apply the formula and then do the simplification whatever is possible. Here the same thing. There should not be any coefficient of x square. So I'm taking 4 out. Which form? Under root x square minus a square. So apply x into under root x square minus a square by 2 minus, here it is minus, a square by 2 log of x plus under root x square minus a square. Alright, x square minus a square plus c. That's it. Take this 2 inside. Take LCM. This 2 will cancel, but this this 4 will come out. It will come out as 2. This 2 will come here also and cancel with this 2. Inside simplify. First of all, inside LCM, this 4 will come out of the under root. It will become 2. LCM with this x. See your class 12, you know how to simplify these small questions now. Is it clear? So I need not to do these steps. First of all, I'll take LCM, then I'll take 4 out of the under root, it will become 2, then I'll take LCM again. This much simplification you all can do. Clear to everyone? Alright, so these are the direct questions related to these forms, but questions will not come direct to you. There would be some twists in the questions. Let's see the next example. I have to integrate x square minus 3x plus 1 upon under the root 1 minus x square. Alright, under the root 1 minus x square. Now, it's a bigger question. Bigger terms like 1, 2, 3 terms in the numerator, 1 term in the denominator. So, first of all, split. Split the integral so that I can convert into different integrals and solve it. Alright. When I was doing under root x square minus a square by parts, I told you, if you have said this is x square, here also x square, there is no other term. So try to make the same function what is there, so that it gets adjusted. ठीक है, नीचे क्या है 1 minus x square, तो मुझे ऊपर 1 minus x square बनाना. Alright, I have to make 1 minus x square. So what am I doing? I am going to add and subtract 1. Add and subtract 1. These all terms will come as it is. Split. From here, these two terms I am taking minus out. Alright. These two are same. Clear? This is, the power is 1 here, the power is half here, so I am left with this. Fine. I know the integration of this 1 upon under root a square minus x square. We have done right now integration of under root a square minus x square. This is left. You have a linear upon quadratic in under root. You don't have to go for that rule. Think about the easiest one, that is a substitution method. If I substitute 1 minus x square, what would be the differentiation? Dx is equals to dt. It will be x dx is equals to minus half dt. Alright, so write the integrations. So I have got this. If I substitute, minus 1 by 2 I will take out, so it will become 3 by 2. 1 upon root t dt. Start integrating. What is the integration of this? This is the form of 1 upon under root a square minus x square. So that is sine inverse x by a plus. This is the form of under root a square minus x square. So what is the differentiation? What is the integration? X into under root a square minus x square by 2 plus a square by 2 sine inverse x by a. Clear? Alright. And this is under root t in the denominator. How it will be integrated? T will go up. Increase the power by 1 divided by increased power. So it will be t raised to power 1 by 2 upon 1 by 2 plus c. Replace the value of t. 2 sine inverse x. And t is 1 minus x square plus c. Is this clear? Alright. 2 sine inverse x minus half sine inverse x. It will become 3 by 2 sine inverse x minus x under root 1 minus x square plus 3 into under root 1 minus x square plus c. You want to take under root 1 minus x square common. That also we can do it. 3 minus x plus c. Is it clear? So if something is not matching with any of the forms which you have done, you need to think. See, I told you thinking in integration is very, very important. You have to bring to the question to a particular form whose integration I know. Then only you will be able to come to the answer. Alright, let's pick up the next one. Little correction here. This 2 was left. Alright, so it will be 2 here. And if I take common from these 2, so it will be 2 here. Alright, so need to be careful while solving the question. We should not miss anything, and otherwise we will come to a wrong conclusion. Let's pick up the last example of this topic. That is, I have to integrate x plus 1 under the root x plus 2 upon x minus 2. If I look at the question, it is not falling under any of the form which we have done till now. So that means what we have to do? Think. Alright. So what am I doing? I'm going to rationalize this. Fine, because up and down we have almost the same number with the opposite sign. So rationalization we should do. A plus b, a plus b, a plus b whole square. That will be a minus b, a plus b, a square minus b square. So that whole square will go out of the integral. So I have reached to the, if I multiply these two, x square plus 3x plus 2 upon, same kind what we did the last question. So I won't be completing it, completely solving it. It's the same kind what we did the fourth example. Now we have reached there. What do we do is split. But उससे पहले ही, because एक part होना चाहिए ऐसा, x square minus 4. So I'm adding minus 4 and subtracting also. When I add, it becomes 6. So that the question gets streamlined in beginning only. So now, this part. Alright. The next one. Now you know each and every part how to solve it, and so that you have to solve on your own. Clear? Just one thing I want to tell. If you remember, this part we did by substitution, and if you remember, I told you in the previous videos, if you have the question like this, f dash x upon f of x, if you have a differentiation exactly, so I write log of f of x. Remember? Okay? There's one more rule. If it is like this, f dash x, and suppose f of function has some power, clear? The function has some power, and I have a differentiation of it's exactly with it, and I have exact differentiation f of n. Suppose it is x square, उसकी differentiation साथ में 2x दे रखी है. So what happens? Directly I can write it, increase the power by 1 divided by increased power. If you remember in the last example this happened. If I put x square minus 4 is equals to t, 2x dx is equals to dt, ये क्या बन जाएगा अंडर रूट t. तो क्या करते हैं ऊपर जाके इंक्रीज द पावर बाय 1 डिवाइडेड बाय इंक्रीज पावर. सो अगर कुछ ऐसा बन जाए कि फंक्शन है किसी पावर के साथ और उसकी एग्जैक्ट डिफरेंशिएशन, द थिंग इज एग्जैक्ट डिफरेंशिएशन साथ में दे रखी है, तो यू डायरेक्टली अप्लाई द रूल इंक्रीज द पावर बाय 1 डिवाइडेड बाय इंक्रीज्ड पावर. You will apply this when you are clear about the things, when you have practiced the things. Otherwise do substitution method, there is no problem. Clear? So इसका differentiation exact करने के लिए क्या चाहिए? अगर मैं इसको substitute करूँ तो what is the differentiation? 2x. So what is missing? 2. Fine. Function ऊपर होना चाहिए. So I'll take this function up. Now I have a function जिसके अंदर वाले फंक्शन की एग्जैक्ट डिफरेंशिएशन, अंदर वाले फंक्शन की, पार की नहीं, fx की डिफरेंशिएशन दे रही है. fx is x square minus 4. इसकी डिफरेंशिएशन दे रखी है. So what is my rule says? Increase the power by 1 divided by increased power. All right. Again, children, very clear. If you think you can't do this way, substitution is the best way of doing it. This part you know how to solve. Sorry. This is the form of under root x square minus a square, and this is the form of 1 upon under root x square minus a square, and both the integration you know. So these are all the examples related to 3 standard forms which we did today. That was under the root x square minus a square, under the root x square plus a square, and under the root a square minus x square.